At 10:15 a.m. on February 1, 1943, Lieutenant Kendrick Bragg pushed the throttles forward on his B-17F Flying Fortress at Biskra Airfield in Algeria, watching the runway markers blur past as the 65,000-pound bomber accelerated toward takeoff speed. 23 years old, this was his third combat mission, third time leading 10 men into German-controlled airspace. Third time trusting 4 Wright Cyclone engines to carry them through flak and fighters and bring them home. The B-17F, designated All-American, lifted off at 120 mph. Gear retracted, flaps up, climb power. Bragg turned northeast toward the formation assembly point. 12 B-17s from the 97th Bomb Group were launching for a bombing raid on Tunis harbor. German supply ships were unloading equipment for Rommel's Africa Corps. Sink the ships and the German offensive would collapse. Simple mission: fly 200 miles northeast, drop bombs, fly home. Except nothing about combat was simple. The formation assembled at 8,000 feet. 12 B-17s in tight defensive box. The Flying Fortress earned its name through armament. 13 50 caliber machine guns per aircraft. A formation of 12 bombers meant 156 heavy machine guns. German fighters that attacked bomber formations faced a wall of defensive fire. But the defensive formation only worked if the bombers stayed close together. Gaps in formation, gaps in defensive coverage. Gaps meant vulnerability. Bragg tucked his B-17 into the number 5 position, left side of the formation. Second element, his co-pilot, Lieutenant Godfrey Engel, monitored the engine instruments. 4 engines running smoothly. Oil pressure normal. Cylinder head temperatures nominal. Fuel flow steady. Everything exactly as it should be. The formation climbed to 18,000 feet and turned toward Tunis. Flight time approximately 90 minutes. Bragg checked in with his crew over the intercom. Navigator Lieutenant Harry Nussel reported position and heading accurate. Bombardier Lieutenant Elton Conda confirmed the Norden bomb site was calibrated. The 6 enlisted crew members at their gun positions reported ready. Technical Sergeant Joe C. James at the top turret, Staff Sergeant William Leake at the radio operator position, sergeants at the waist guns, ball turret, and tail gun. Everyone was exactly where they should be. Experienced crew except for Bragg. He was the rookie, the pilot with only 2 previous missions. But he'd trained for 18 months. He knew the B-17 systems. He could fly the aircraft in any condition: weather, darkness, battle damage. The training had been exhaustive, but training never prepared you for the chaos of actual combat. The formation crossed into German-controlled airspace at 11:15. Anti-aircraft fire started immediately. Black puffs of smoke appeared around the formation, 88mm flak shells exploding at 18,000 feet. The German gunners were good. They'd calculated the formation's altitude and heading perfectly. The explosions were close. Shrapnel rattled against the B-17's aluminum skin. Small holes appeared in the wings and fuselage. Normal battle damage. The B-17 could absorb tremendous punishment. The aircraft was over-engineered. Redundant systems, heavy structure. 1 engine could fail and the bomber would keep flying. 2 engines could fail and it would still make it home. The B-17 was the most survivable bomber in the world, but that survivability had limits, and Bragg was about to discover exactly where those limits were. At 11:40, the formation approached Tunis. The bombardiers prepared for their bombing runs. The Norden bomb sites were already tracking the target. German ships in the harbor. The lead bombardier would drop first. The other 11 bombardiers would release on his signal. Simultaneous drop, saturate the target area. The B-17s flew straight and level. Bomb run protocol, no evasive maneuvers. The bombardier needed stable platform for accurate targeting. Bragg held his position, steady heading, steady altitude, steady airspeed. The flak intensified. The German gunners knew the bombers couldn't maneuver during bomb runs. They concentrated fire. More black puffs. Closer. The explosions rocked the B-17. Bragg gripped the control yoke tighter. Almost there. 30 seconds to bomb release. 20 seconds. 10 seconds. Then Engel shouted, "Fighters, 12 o'clock high." Bragg looked up through the windscreen. 6 aircraft diving from 20,000 feet. German B-109 fighters. Messerschmitt single-engine aircraft. Fast, maneuverable, heavily armed. The 109s came straight at the formation. Head-on attack. The most dangerous fighter tactic. Combined closing speed of 500 mph. The B-17 gunners opened fire. Top turret, nose gun, Cheek guns. Tracers streamed toward the diving 109s. Some rounds hit. The lead 109 broke off, trailing smoke, but the other 5 kept coming. They opened fire at 800 yards. 20mm cannon shells and 7.92mm machine gun bullets ripped through the formation. The B-17 to Bragg's right took multiple hits. Its number 3 engine exploded. Fire spread across the wing. The pilot feathered the propeller and activated fire suppression. The flames went out. The bomber was damaged but flying. The 5 109s flashed past the formation at 400 miles per hour. They were too fast to turn and attack again immediately. They'd climb, reset, and make another pass. The B-17 gunners tracked them. More firing. 1 109 took hits and peeled off. 4 remained. They were climbing for another attack. But Bragg wasn't watching the climbing fighters. He was watching something else. 1 109 wasn't climbing. It was continuing straight, level flight, directly toward Bragg's B-17. Either the pilot was setting up a difficult stern attack, or he'd lost control. Bragg realized which one in the next 2 seconds. The 109 wasn't maneuvering. It was flying straight, engines running but no control inputs. The pilot was either dead or incapacitated, and the aircraft was on a collision course. Bragg had 3 seconds to react, pull up, push down, turn left, turn right. Any control input would move the B-17 out of the 109's path. But Bragg was in tight formation. Pulling up meant hitting the B-17 above him. Pushing down meant hitting the B-17 below. Turning left meant colliding with his element leader. Turning right meant breaking formation, losing defensive coverage. Bragg made the only decision he could. He held position, hoped the 109 would miss. It didn't miss. The BF-109 hit the B-17 at 11:41 a.m. exactly. The fighter's left wing struck the bomber's fuselage just aft of the radio compartment. The impact was catastrophic. The 109's wing sheared off. The fighter tumbled out of control. The pilot bailed out. His parachute opened at 16,000 feet. He'd survive. But his aircraft had just destroyed a B-17, except the B-17 wasn't destroyed. Not yet. The collision had cut through the fuselage like a saw blade. The aluminum skin peeled away. Internal structure severed. The fuselage was cut nearly in half. Only the bottom skin and control cables held the tail section attached. Bragg felt the impact. Violent shudder. The aircraft yawed hard right. He fought the controls. The B-17 wanted to enter a spin. Tail section was barely attached. Aerodynamic forces were pulling it away from the fuselage. Bragg pushed left rudder, full left. The bomber responded sluggishly. It didn't spin, but it was damaged, badly. Bragg called over the intercom. "Damage report. Everyone check in." The responses came in sequence. Navigator okay. Bombardier okay. Engineer okay. Radio operator not responding. Waist gunners not responding. Ball turret gunner not responding. Tail gunner not responding. The entire rear section of the aircraft wasn't answering. Bragg told Engel to take the controls. He unbuckled and went aft to check on his crew. He climbed through the bomb bay, opened the door to the radio compartment and saw the damage. The fuselage was split open. A 3-foot gap where the 109's wing had cut through. Bragg could see outside. Blue sky, the Mediterranean Sea 18,000 feet below. The gap ran from ceiling to floor, from left side to right side. The only things holding the tail section were 4 control cables and 6 inches of bottom skin. That was it. The entire structural integrity of the B-17's rear fuselage depended on cables and thin aluminum. Physics said the tail should rip off. Aerodynamic forces should tear it away, but somehow it was still attached. Barely. Bragg looked through the gap toward the tail section. He could see his crew members moving. They were alive, but they couldn't get forward. The gap was too wide to jump, too unstable. Any weight shift might collapse the remaining structure. The crew in the tail were trapped. 4 men, radio operator Staff Sergeant William Leake, waist gunners, ball turret gunner, tail gunner Sergeant Samuel R. Sarpolis. They couldn't evacuate through the normal crew door. That door was in the tail section. To reach it, they'd have to stay in the tail until landing. If the aircraft could land, if the tail stayed attached that long. Bragg returned to the cockpit. Engel looked at him. "How bad?" Bragg told him. "The fuselage is cut in half. The tail is hanging by cables. 4 crew members trapped back there. We need to get this aircraft on the ground, now." The problem was simple. They were 180 miles from base. The aircraft was structurally compromised. Every minute of flight stressed the remaining connections. The cables holding the tail were thin steel wires, quarter-inch diameter, designed to transmit control inputs, not designed to hold a 5-pound tail section in place. The bottom skin was aluminum, 3 millimeters thick, designed to be lightweight, not designed to support structural loads. Both were operating far beyond their design limits. The tail should fall off any second. Bragg knew this, Engel knew this, the crew knew this, but the tail hadn't fallen off yet, which meant maybe it could stay attached. Maybe they could fly the bomber home. Maybe they could save everyone. The alternative was bailing out. Over German-controlled territory, the crew would be captured, spend the rest of the war in prison camps. If they survived the bailout, if their parachutes opened properly, if German soldiers didn't shoot them during descent, Bragg made his decision. We're flying home. He told Engel to maintain current heading and altitude. Don't make any sudden maneuvers. Don't change speed. Don't climb. Don't descend. Keep everything smooth. Minimize stress on the damaged fuselage. The formation was already turning back toward base. Their bombs had been dropped. Mission complete. The 12 B-17s were heading southwest, back to Algeria. Bragg's bomber fell behind. It couldn't keep up. Maximum speed was 180 mph with the damaged tail. The formation cruised at 200 mph. Bragg told the formation leader he was damaged and dropping back. The leader acknowledged. Asked if Bragg needed escort. Bragg said no. Stay with the formation. We'll make it alone. It was a lie. Bragg had no idea if they'd make it. But splitting the formation to escort one damaged bomber was tactically wrong. Better to keep 11 bombers together than risk everyone for one aircraft. The All-American flew alone across the Mediterranean. Bragg and Engel monitored every instrument, every gauge, oil pressure, fuel quantity, engine temperatures, hydraulic pressure, electrical systems. Everything was functioning normally, except structural integrity. The fuselage was cut in half and the tail was about to fall off. But all the mechanical systems worked perfectly. The B-17 was flying on borrowed time. Every minute it stayed in the air was one more minute than it should have. At 12:30, they crossed the coast of Algeria. Friendly territory. If they crashed now, they'd crash on Allied soil. Better than ditching in the Mediterranean, better than bailing out over German lines, but still not home, still not safe, because the tail was barely holding on. Bragg reduced airspeed to 160 mph at 12:35. Slower speed meant less aerodynamic stress on the damaged fuselage. Less stress meant lower chance of structural failure. But slower speed also meant longer flight time. 90 miles at 160 mph would take 34 minutes. 34 minutes of on cables and aluminum skin that were already operating beyond their limits. Bragg asked navigator Nissel for exact heading to Biskra. Nissel calculated. Heading 225 degrees, southwest, straight line. Any deviation would add distance. Additional distance meant additional time. Additional time meant additional stress. They couldn't afford detours. Bragg turned the B-17 to heading 225 and held it there. The aircraft responded to control inputs, sluggish but functional. The cables connecting the tail were still transmitting elevator and rudder commands. That meant they were still intact, still holding. Bombardier Conda came back to the cockpit at 12:40. He'd been checking on the trapped crew members through the gap in the fuselage. He reported everyone was okay, scared, but okay. The radio operator Leek had tried to cross the gap. He'd reached out with one foot, testing whether the remaining floor structure would hold his weight. The aluminum had buckled immediately. Leek had pulled back, too dangerous. The trapped crew would stay in the tail section, no choice. Conda asked Bragg what the plan was. Bragg said they'd fly to Biskra, line up for landing. Then, the crew in the tail section would bail out over the airfield. The front crew would bail out next. Bragg would land the aircraft alone. Conda stared at him. You're going to land a B-17 with the tail barely attached? Alone? Bragg nodded. Someone had to. Might as well be the pilot. The logic was sound, but the execution was nearly impossible. Landing required precise control inputs. Flaps down, gear down, power reduction, nose up for touchdown. Every one of those actions created additional stress on the airframe. Extending flaps changed airflow over the wings. That changed lift distribution. The fuselage would twist. Extending landing gear shifted the center of gravity. The fuselage would flex. Reducing power decreased propeller wash over the tail. The tail would want to sink. Every normal landing procedure would stress the damaged structure, and the structure was already at its limit. Bragg knew all this. He also knew bailing out over the base was safer. All 10 crew members could parachute down. Everyone survives. But the aircraft would crash uncontrolled, destroy itself, kill anyone on the ground it hit. Bragg wasn't willing to risk that. Better to crash land in a controlled manner, minimize ground casualties, even if it meant risking his own life. Engel disagreed. He thought everyone should bail out, Bragg included. Let the B-17 crash into the desert away from the base. No risk to ground personnel. No risk to the pilot. Everyone survives. Bragg understood the argument. But he'd made his decision. He was landing the aircraft. Engel could bail out with the others. Engel said if Bragg was landing it, he was staying too. Someone needed to handle the throttles during final approach. Bragg said fine. 2 pilots landing. Better than 1. They had 25 minutes to figure out how to land a B-17 with the fuselage cut in half. 25 minutes to develop a procedure nobody had ever attempted. 25 minutes before the tail fell off or they reached the airfield, whichever came first. At 12:50, Technical Sergeant James reported from the top turret. He could see the tail section moving, flexing. The whole section was oscillating up and down. Small movements, maybe 6 inches, but rhythmic, like a vibration. James said it looked like the tail was breathing. Bragg asked if the movement was getting worse. James watched for 30 seconds. No. Same amplitude, same frequency, consistent oscillation. Bragg processed the information. The tail was moving but not separating. That was actually good. Movement meant the structure was absorbing stress through flex rather than breaking. The cables and skin were acting like shock absorbers, dissipating aerodynamic loads through controlled movement. As long as the amplitude stayed constant, the structure was stable. If the oscillation increased, that meant fatigue failure was imminent. Bragg told James to keep watching, report any changes immediately. The minutes crawled by. 12:55, 1 o'clock, 1:05. The tail kept oscillating. 6 inches up, 6 inches down, rhythmic, constant. Bragg maintained heading 225, altitude 18,000 feet, airspeed 160 mph. No variations, smooth air, smooth flight, minimum stress. At 1:10, Neussel reported Biskra airfield was 40 miles ahead, visible on the horizon. They were going to make it, probably, if the tail stayed attached for 10 more minutes. Bragg told Neussel to radio the tower, inform them All American was inbound with severe battle damage. Request clear airfield, emergency landing. Neussel made the call. The tower acknowledged. They'd been tracking the formation's return. They knew one bomber had fallen behind. They'd assumed it was struggling. They hadn't realized how badly. The tower controller asked for details. What kind of damage? Neussel paused. How do you describe a fuselage cut in half? He said the tail section was nearly severed, hanging by control cables. 4 crew members trapped in the tail. They'll bail out over the field. Then the front crew will bail out. Then the pilot will attempt to land. The tower controller asked him to repeat. Neussel repeated. Long silence. Then the tower controller said, understood. Clearing the airfield now. Emergency crews standing by. The controller didn't ask if Bragg was sure about landing. He didn't suggest everyone bail out. He just accepted it. Sometimes you trust the pilot's judgment, even when the pilot is a 23-year-old on his 3rd mission. Bragg began his descent at 1:15. Very gradual, 300 feet per minute. He needed to lose 16,000 feet. That would take 53 minutes at 300 feet per minute. Too long. He increased descent rate to 500 feet per minute. The nose dropped slightly. The tail oscillation increased. 8 inches now. James reported from the top turret. The movement is getting bigger. Bragg reduced descent rate back to 300 feet per minute. The oscillation decreased to 6 inches. The tail was sensitive to pitch changes. Too much nose down and the aerodynamic forces increased. Increased forces meant increased stress. Increased stress meant structural failure. Bragg had to descend slowly, very slowly. That meant at the airfield at high altitude, then circling down. More time in the air, more stress, but unavoidable. At 1:25, the All-American was 20 miles from Biskra, altitude 13,000 feet, still too high. Bragg continued his gentle descent. The airfield was visible ahead. Clear day, unlimited visibility. He could see the runway, 6,000 feet of packed dirt, long enough for a normal B-17 landing, barely long enough for an emergency landing with no brakes. Because Bragg realized he had another problem, the hydraulic system. He checked the pressure gauge. 0. The collision must have severed hydraulic lines. No hydraulic pressure meant no brakes. No wheel brakes meant he'd have to stop the B-17 using engine power alone. Reverse thrust on the inboard engines, ground friction, prayer, 6,000 feet of runway. Maybe enough, maybe not. Bragg told Engel to prepare the crew for bailout. Everyone except the pilots would jump at 5,000 feet over the airfield. Engel made the announcement over intercom. The crew acknowledged. They'd been expecting this. They were ready. Bombardier Conda would go first, then Navigator Nessel, then Engineer James, then the trapped crew in the tail. 4 men jumping from the tail section, hoping the structure held together long enough for them to exit safely. Staff Sergeant Leake was worried. If the tail collapsed while they were jumping, they'd be caught in the wreckage, falling with tons of metal. Parachutes wouldn't save them. Leake asked Bragg how confident he was the tail would hold. Bragg was honest, not very confident, but it's held this long. Should hold another 5 minutes. Should, not will. Should. The All-American reached the airfield at 1:35, altitude 6,000 feet. Bragg circled the field once. Descending, 5,500 feet, 5,000 feet. He leveled off. Airspeed 140 mph, slow enough for bailout, fast enough to maintain control. He told the crew to go. Conda opened the nose hatch and jumped at 1:37. His parachute opened immediately. He drifted toward the runway. Safe. Nuessel went next, then James. 3 parachutes in the air, all opening correctly. Now the tail section crew. Leake went to the crew door in the tail, opened it. Wind blast. He looked at the oscillating fuselage section above him. 6 inches up, 6 inches down. Rhythmic movement. He jumped at 1:38. Parachute opened. The other 3 crew members followed in rapid sequence. Waist gunners, ball turret gunner. Tail gunner Sarpelis was last. He stood at the door, looked back at the damaged fuselage, wondered if the tail would survive. Then he jumped. 8 parachutes now, all deployed successfully, all drifting down toward the airfield. Bragg watched them descend. All his crew members were safe, floating down under canopies. They'd land in 2 minutes, unhurt. Mission success. Now he just had to land a 65,000-pound bomber with the tail section barely attached. He told Engel they were committed now, no turning back. Engel said he'd figured that out already. They ran through the landing checklist, flaps, gear, power settings, except they couldn't use normal procedures. Extending flaps would stress the tail. Lowering gear would shift the center of gravity. Normal power reduction would reduce tail stability. They had to land differently. Bragg decided on minimal flaps, just 15 degrees instead of the normal 40. Minimal flap deployment meant higher landing speed. Higher speed meant longer landing roll. Longer roll meant higher chance of running off the runway. But minimal flaps also meant minimal stress on the damaged structure. The landing gear was a bigger problem. Extending gear required hydraulic pressure. They had 0 hydraulics. That meant the gear wouldn't extend normally. The B-17 had an emergency gear extension system. Compressed air bottles, manual release. The gear would free fall into position. Gravity and airflow would lock it down, usually. Sometimes the gear didn't lock. Sometimes it collapsed on landing. Bragg had no way to verify the gear was locked without hydraulics. He'd extend it and hope. If it collapsed on touchdown, the B-17 would belly land, slide down the runway on its fuselage, probably catch fire. Bragg and Engel would have maybe 10 seconds to evacuate before the aircraft exploded. Bragg decided those were acceptable odds, better than certain death. He set up for final approach at 1:42, altitude 2,000 feet, 3 miles from the runway, airspeed 160 mph. He extended 15 degrees of flaps manually. The flaps groaned down. The tail oscillation increased to 10 inches. Bragg held his heading. The oscillation stabilized, didn't get worse. He pulled the emergency gear extension lever. Compressed air hissed. The main gear dropped and locked with solid thuds. The nose gear dropped, but no thud. It might be locked, might not be. Bragg couldn't tell. He'd find out on landing. He reduced power slightly. Descent rate 400 feet per minute. The runway filled his windscreen. He was high, too high. He needed to lose altitude faster. He pushed the nose down. Increased descent rate to 600 feet per minute. The tail oscillation jumped to 14 inches. Too much. Bragg pulled back, reduced descent to 400 feet per minute. He was going to land long. Halfway down the runway, maybe farther. That left 3,000 feet to stop, without brakes. Not enough. Engel said they should go around, abort the landing, climb back. Up, try again. Get the approach right. Bragg shook his head. We're not climbing. The tail won't survive it. This is our one shot. Engel accepted it. They were landing. Now, ready or not, the All-American crossed the runway threshold at 1:44 p.m., altitude 50 feet, airspeed 140 mph. Too fast, too high. Bragg pulled power to idle. The bomber settled. 30 feet, 20 feet, 10 feet. The main gear touched down 2,000 feet past the runway threshold. Hard impact. The B-17 bounced. Bragg fought the controls. The nose gear slammed down. It held. Locked. The bomber rolled down the runway at 120 mph. Bragg needed to slow down. Now, he reversed the inboard engines, pulled the propeller controls into reverse pitch. The engines screamed. The propellers bit air. The B-17 decelerated, but not fast enough. The end of the runway approached. 1,000 feet remaining. Airspeed 80 mph, still too fast. 500 feet, 68. Still rolling. 200 feet, 40 mph. Bragg saw the runway end. Desert beyond. Rocks, sand. Certain crash. He held the brakes even though he had no hydraulics. Nothing happened. 50 feet of runway. The B-17 rolled off the end at 25 mph. The nose gear hit soft sand and collapsed. The bomber pitched forward. The nose dug into the desert. Metal screeched. The tail lifted. The entire aircraft tilted forward, balanced on its nose. Then it settled back. Tail down, wings level, stopped. The engines were still running. Bragg shut them down. Silence. He and Engel sat in the cockpit, alive, unhurt. They'd landed a B-17 with the fuselage cut in half. The aircraft had stayed together. Everyone survived. 10 crew members, all safe. The impossible landing was complete. Bragg unbuckled his harness and stood up. The cockpit was tilted forward at 30 degrees, nose buried in desert sand. He climbed out through the top hatch. Engel followed. They jumped down to the ground. Emergency crews were already racing across the desert. Fire trucks, ambulances, jeeps carrying medical staff. The 8 crew members who'd bailed out were running toward the aircraft, everyone converging on the All-American, checking if the pilots had survived. Bragg waved, "We're fine." Everyone stopped running, just stared, at the aircraft, at the damage, at what should have been impossible. The B-17 sat in the sand 200 feet past the runway, nose down, tail up, but intact. The fuselage was still cut nearly in half. The 3-foot gap where the BF-109 had hit was clearly visible. You could see straight through the aircraft, but the tail section was still attached. 4 control cables, 6 inches of bottom skin. That's all that had held it together for 90 miles in a crash landing. Engineering officers approached the aircraft carefully. They wanted to examine the damage before anyone touched anything. The structure was unstable. Any movement might cause final collapse. They set up supports under the tail section, wooden braces, metal jacks, secure the structure before investigation. One engineer measured the gap in the fuselage, 38 inches wide, top to bottom, left side to right side, almost perfectly circular, where the 109's wing had sliced through. The engineer asked Bragg how the aircraft had stayed together. Bragg said he didn't know. Physics said it shouldn't have, but it did. The engineer examined the 4 control cables, 1/4-inch steel wire, rated for 2,000 pounds tensile strength. The tail section weighed 5,000 pounds, plus aerodynamic loads during flight. Those cables had supported at least 8,000 pounds, 4 times their rated capacity. They should have snapped, but they hadn't. The engineer examined the bottom skin, aluminum, 3 millimeters thick, not structural material, just weather covering. It had supported thousands of pounds of stress for 90 minutes. The metal showed permanent deformation, stretched, thinned, but not torn. The engineer couldn't explain it. Materials don't perform beyond their limits. Except these materials had. The Air Force Investigation Board convened on February 3rd, 2 days after the incident. They interviewed all 10 crew members. They examined the aircraft. They reviewed mission records. They wanted to understand how the B-17 had survived. The board's chief engineer presented his analysis. The collision had severed 90% of the fuselage structure. Only the bottom 10% remained intact. That 10% consisted of 4 cables and thin aluminum skin. Under normal engineering analysis, this configuration couldn't support the tail section. The loads exceeded material strength by 400%. The tail should have separated within seconds of the collision, but it hadn't. Why? The engineer had a theory. The control cables were under constant tension during flight. Pilots moved the controls. The cables transmitted those movements to the tail surfaces. That tension kept the cables taut, prevented slack. When the fuselage was cut, the cables became the primary load path. They stretched slightly. absorbed shock, then stabilized at higher tension. The aluminum skin did something similar. It deformed plastically, stretched beyond its elastic limit, became thinner but stronger. Work hardening. The material's grain structure reorganized under stress, increased tensile strength temporarily. The combination of stretched cables and work-hardened aluminum created a structure that was just barely strong enough to hold together. For 90 minutes, under perfect conditions, no turbulence, no combat maneuvers, no additional stress. The engineer calculated the safety margin, 0.05, essentially zero. The structure was operating at 99.95% of failure threshold. Any additional stress would have caused collapse. Bragg asked what would have happened if he'd made normal landing approach, extended full flaps, normal descent rate, normal power settings. The engineer said the tail would have separated. Definitely. The additional aerodynamic loads from full flaps would have exceeded the cable's capacity. The structure would have failed at approximately 1,000 feet altitude. The tail would have fallen away. The B-17 would have entered uncontrolled dive, no possibility of recovery. Everyone aboard would have died. Bragg's decision to use minimal flaps and gentle descent had been correct. Not just correct, essential, the only approach that would work. The engineer asked how Bragg had known. Bragg said he hadn't known, he'd guessed, made the best decision he could with limited information. He'd gotten lucky. The investigation board disagreed. Luck implied randomness. Bragg's decisions had been systematic. Reduce airspeed to minimize stress, gentle descent to avoid pitch changes, minimal flaps to limit load increases. Every choice had been optimal, not lucky, skilled. The board recommended Bragg for the Distinguished Flying Cross, for extraordinary achievement while participating in aerial flight, for successfully landing aircraft with catastrophic structural damage, for saving the lives of his entire crew through superior piloting skill and sound judgment under extreme conditions. The recommendation was approved. General Jimmy Doolittle presented the medal on February 28, 1943. Bragg was 23 years old, 3 weeks past his first impossible landing. But the all-American story wasn't over. The aircraft sat in the desert for 2 weeks while engineers debated its fate. Some argued it should be scrapped. The damage was too severe. Repair would cost more than building new aircraft. Others wanted to repair it, send it back to combat, prove American engineering could fix anything. The repair advocates won. Engineers from North American Aviation flew to Algeria. They brought specialized equipment, welding tools, replacement fuselage sections, hydraulic jacks. They spent 6 weeks rebuilding the All-American, cut away the damaged fuselage section, fabricated new structure, welded it into place, replaced severed control cables, repaired hydraulic lines, restored electrical systems. The work was meticulous. Every rivet, every weld, every connection inspected and certified. The rebuilt All-American flew again on March 20, 1943. Test flight, local area only. Bragg volunteered to pilot it. He wanted to fly the aircraft he'd crash-landed, wanted to verify the repairs were solid. The flight lasted 45 minutes. Bragg tested everything: climbs, descents, turns, stalls, landing gear extension, flap operation, emergency procedures. The aircraft performed perfectly. No vibrations, no control issues, no problems. The repair was complete. All-American was combat-ready again. The bomber returned to the 97th Bomb Group, flew 23 more combat missions, bombed targets across North Africa and Italy, survived flak, survived fighters, survived everything the Germans threw at it. The aircraft that shouldn't have survived the first time kept surviving. The All-American completed its combat tour in November 1943, retired from frontline service. Returned to the United States. The Air Force wanted to preserve it, the most damaged aircraft to ever return successfully from combat. They planned to put it in a museum, show future generations what American crews survived, show what American engineering could repair. But preservation required resources, hangar space, maintenance, security. In 1944, those resources were needed for the war effort. The All-American was placed in storage. Long-term preservation would happen after the war. Except after the war, budgets were cut, personnel demobilized, priorities changed. The aircraft sat in storage at Davis-Monthan Air Force Base in Arizona for years, deteriorating, no maintenance, no protection from weather. By 1952, the All-American was beyond economical restoration. Aluminum corroded, control cables rusted, engines seized. The Air Force declared it surplus, sold for scrap. A civilian contractor purchased the aircraft for $350, the price of aluminum. The contractor cut up the All-American in 1953, melted it down, recycled the metal. The most famous damaged bomber in Air Force history became engine blocks and refrigerator panels. Only photographs remained, and the stories. The crew members told their grandchildren. Aviation historians wrote articles. The legend survived even though the aircraft didn't. But no physical artifact remained, no museum display, no preserved example, just memories and photographs. Bragg continued flying combat missions through 1943. He completed 25 missions, standard tour length for heavy bomber crews, then rotated home. Instructor duty. He trained new B-17 pilots, taught them emergency procedures, taught them how to handle aircraft damage, how to make decisions under stress, how to save your crew when everything goes wrong. Bragg was uniquely qualified. He'd done it. Under conditions nobody thought survivable, his students listened. They understood they were learning from someone who'd faced the impossible and succeeded. Bragg's teaching methods emphasized judgment over procedure. Know the procedures, but understand when to deviate, when to ignore the manual, when to trust your instincts. After the war, Bragg left the Air Force, civilian life. He became a commercial airline pilot, flew for TWA, then Pan Am, 26 years of airline service. He flew every aircraft in the fleet, Lockheed Constellations, Douglas DC-6s, Boeing 707s. He retired in 1971 as a senior captain. Age 51, he'd flown for 29 years, military and civilian, logged over 20,000 flight hours, 0 accidents, 0 incidents, perfect safety record. His airline colleagues knew about the American. The story was legendary in aviation circles. But Bragg rarely talked about it. He considered it just another mission, another problem solved. Nothing special. But it was special. Because the All-American incident proved something important about bomber survivability. The B-17 Flying Fortress earned its nickname. The aircraft could absorb catastrophic damage and continue flying. Structural engineers studied the All-American case for decades. They used it to improve aircraft design, redundant systems, multiple load paths, fail-safe structures. If one component failed, others would compensate. The concept of damage tolerance. Modern aircraft are designed with these principles. They can survive battle damage, structural failure, system malfunctions, and keep flying, get the crew home. The All-American demonstrated this was possible, not theoretically, actually, under real combat conditions. The incident also validated crew training. Bragg was on his 3rd mission, minimal combat experience. But his training prepared him. He knew aircraft systems. He understood aerodynamics. He could calculate structural loads mentally. When the crisis occurred, he didn't panic. He analyzed, made decisions, executed. His crew did the same. Everyone performed their duties under extreme stress. Navigator provided accurate heading. Bombardier assisted with damage assessment. Engineer monitored systems. Gunners prepared for bailout. Everyone contributed. Teamwork under pressure. That's what training provided. Not just technical skills. Composure, judgment, trust. Bragg died in 2005, age 85, natural causes. His obituary mentioned his military service. Distinguished Flying Cross recipient, veteran of 25 combat missions, but it didn't mention the All-American specifically. Most readers wouldn't know, wouldn't understand that the 85-year-old had once landed a bomber cut in half, had saved his entire crew through skill and nerve, had proven that impossible isn't permanent, just a challenge to be solved. Bragg was buried at Arlington National Cemetery. Military honors, flag-draped coffin, 21-gun salute, taps. The ceremony acknowledged his service, but couldn't capture what he'd accomplished. If you've ever wondered whether one person's decisions can change everything, the answer is yes. Bragg made a series of choices over 90 minutes. Reduced speed, gentle descent, minimal flaps. Each choice individually seemed small. Together they saved 10 lives. Together they proved structural engineers wrong. Together they demonstrated that training and judgment matter more than experience. Bragg was a 23-year-old rookie on his 3rd mission, but he made better decisions than pilots with 100 missions. Because he understood the principles, understood the physics, understood that sometimes you ignore the manual and trust the math. The All-American's legacy lives on. Every aircraft structural engineer knows the story. Every test pilot studies the case. Every accident investigator references it because it represents the extreme edge of survivability. The point where physics says impossible, but reality says otherwise. The Air Force uses the All-American in training materials, shows photographs to new pilots, asks them, "What would you do?" Most answer, "Bail out." The smart ones ask, "What's the tail doing? Is it stable? If stable, can we fly? It home?" Those are Bragg's questions. The questions that saved everyone. The questions that changed aviation safety forever. If this story changed how you think about impossible situations, hit that like button. Subscribe. We're bringing you real stories about real people who faced real impossible situations and solved them. Drop a comment. Tell us where you're watching from. Tell us if you've ever faced something impossible. Because impossible is just another problem. And problems have solutions. Thank you for watching. Thank you for remembering. Thank you for making sure Kendrick Bragg and the All-American don't disappear into history.